I'm going to spend a few moments here and go through the answers for the 4.3 study guide. We're going to look at pH calculations. We're going to look at acids and their conjugate bases, bases and their conjugate acids, and finally conjugate acid-base pairs. Now we can see here on the picture that we have ammonia, NH3, and because it has this pair of electrons that's not bonded anything, then it is able to accept a proton, accept an H+. So if it's going to accept, that means it's a base. And after it has accepted, then this is the conjugate acid. In the same way that we have water, which has H's, has protons, and it can donate one of those protons in this case, so that means it is an acid, and after it has donated, now it's a conjugate base, because it can accept. Looking at this first problem, we can do the first several of them just in our heads. So we have several rules that we've been using for this, and one is the idea that, if you know the H plus and the OH minus, you can go back and forth between these because when you multiply together they equal 1 times 10 to the minus 14 or 10 times 10 to the minus 15. The other thing is that the pH and the pOH always add up to 14. So if you know the pH or the pOH, you can find the other. Now the H plus concentration turns into the pH. We can make this conversion because the pH equals the negative log of the H plus concentration, which means the negative of the exponent, or if you're doing a fancy calculation, use your calculator. And the opposite that is that the H plus concentration is 10 to the negative pH. Similarly, on the OH side, that the pOH is the negative log of the OH minus concentration, and the OH minus concentration is 10 to the negative pOH. So we've seen these before. So let's go back and use these ideas to solve our problems. So the first thing we'd look at is, the H plus is 1 times 10 to the minus 10, so the pH must be 10. And we're going to find out that as 10.00. Now, if we know the pH, then we can go back and say that this is basic. Anything larger than 7 is basic. If we know the pH is 10, we know the pOH adds up to 14, so it must be 4. And therefore the OH concentration must be 1 times 10 to the negative 4. So we just do all that in our head. Okay, second one. If we know the pH is 5, then we know that this is acid, because anything less than 7. And we know the pOH, because 14 minus 5 is 9. And this will be 1 times 10 to the negative 5. And 1 times 10 to the negative 9. So all we have to do is look at the number here, and we're going to use that as the negative of our exponent. Okay, going back, if we know that the pOH is 11, we know that the pH must be 3 because they add up to be 14. And if the pH is 3, we know this is an acid. And we go back, and now we say, well, the first number, our H plus concentration, 1.0 times 10 to the minus 3, and this would be 1.0 times 10 to the negative 11. The last one here, we can do D, we can still do this in our head. 1 times 10 to the minus 3, so we know that the pOH must be 3. And if the pOH is 3, we know the pH is 11, because they add up to 14. If the pH is 11, we know this must be a basic solution, anything larger than 7. Now we can go back and put in our original number, 1.0 times 10 to the negative 11. Now for the other numbers here, we need to use our calculator. So I would start here and say, if I know my OH minus concentration is 3.5 times 10 to the minus 8, I'm just going to say 1 times 10 to the minus 14 divided by 3.5 times 10 to the minus 8, and I get an answer of 2.6 times 10 to the negative 7 using my calculator. Now, my pH is going to be somewhere between 6 and 7, and it turns out to be 6.54 rounded off. Then I know that this must be an acidic solution. And if I know 6.54, I can subtract from 14, get 7.46 for my POH. In the same way, if I have my pH as 7.20, then subtract from 14, I know my POH must be 6.80. Also, if I know my pH is 7.2, that's greater than 7, so this is slightly basic. Now I have to use my calculator and say 10 to the negative 7.2 and 10 to the negative 6.8 to get my H plus concentration and my OH minus concentration. My H plus concentration comes out to be 6.3 times 10 to the negative 8. And that's taking 1 times 10 to the negative 14. No, it isn't. It's taking 10 to the negative 7.2. And to get my other number, I'm going to figure that's 1.6 times 10 to the negative 7. And again, those are slightly rounded off. Now the last two numbers on here, I can take my negative 0.80, and since I know that they add up to 14, this must be 14.80, because that adds up to 14. That's going to be a very, very basic solution. Okay, if I say 10 to the negative 14.8, I get 1.6 times 10 to the negative 15, which is very, very concentrated. No, it's a very dilute solution. And my 10 to the negative 0.8, which will be 10 to the 0.8, is 6.3. And remember, these are all molarities. That's a very concentrated basic solution. And finally, knowing that my H plus concentration is 1.9 times 10 to the minus 2, I can divide that into 1 times 10 to the negative 14, and I get a very, very large number here, 5.3 times 10 to the negative 17. So my pH is going to end up being negative 2.28, because when I take the negative log of 1.9 to 10 to the minus 2, I get negative 2.28, and my POH will be 16.28. So this is going to be a very, very acidic solution. And I would be able to get all those numbers by using the rules that we had down here. That I could multiply two numbers to get 1 times 10 to the minus 14. I could take the negative log of my values or work it backwards, taking the concentration is 10 to the negative pH or POH. And remember, the pH plus POH always adds up to 14. Now the second kind of problem is asking for the conjugate acid or conjugate base if you can tell whether something is an acid or a base. And some of these are a little subtle. So the first one, you see the NH2, that means it's an amine. Amines are bases. Amines are bases. Now bases accept protons, H pluses, and so therefore they have a conjugate acid. So this is not going to have a conjugate base because it is a base, so it's going to have a conjugate acid. So all we have to do is just add in an H plus. So we just have to add H plus to the formula. And over here we're going to remove an H plus from the formula. So we would have CH3 NH3 plus. So I've added an H and a plus, and it goes on the NH3 part. Okay, the second one, this could act as an acid or a base. So I'm going to say this guy here was a base. Okay, this guy could be a base because it could accept H plus, in which case it would become H2SO4. But it could also donate an H plus, so I'm going to remove an H plus and just have SO4 2 minus. So when we have a substance that can be acid or base, we say that it is amphoteric. Now the Cn minus, it does not have an H, so it cannot be an acid, cannot donate, but it can accept, and if it does, we give it an H plus and become HCN, hydrocyanic acid. H3O plus, on the other hand, can donate, does have H's, and if it does, becomes H2O, and I've never seen that act as a base. I've never seen H4O2 plus. So HBrO3, that's easy. We can see that that's an acid. So when because it starts with an H. So when it is an acid, it donates. I'm going to remove an H plus, and its conjugate base will be BrO3 negative. The HNO3, we can see the NO3 minus has no H, so it cannot act as an acid, but it could act as a base. It could accept an H and become HNO3 1 minus. No, just HNO3. Now this one here again, we have NH3 plus, so we can see that's an amine. It's like this guy, amine that has accepted, so it could donate, so it can act as an acid and become C3H7NH2, turn into an amine, and I don't see how it could accept anything. OCl minus, okay, it does not have an H, so it cannot accept, so it has to become HOCl, okay, which is hypochloric acid. The last question here I think is the easiest one. If you just pick out any chemical and say here it is and let's see it later, well, it has gained a proton, so this must be a base, and so this must be its conjugate acid. And if this is the base, this is an acid, and this must be its conjugate base. So as soon as you pick out any one of the chemicals and what it does, then you know what everything else is doing. So here we have NH plus turning into C5H5N. So it has lost the H plus, which means it donated. So this is an acid. This must be the base. This must be the conjugate base, and this would be the conjugate acid. Again, HCO3 minus turning into there, it just gained a proton, so it's a base, so this must be acid. This will be the conjugate acid. The last one will be the conjugate base. H2O, H3O plus, okay, just like the first one, this has gained a proton, so that's a base, and this is its conjugate acid. So this must be an acid, and this will be its conjugate base. Finally, we'll take the underlined HOCl. To turn into OCl minus, it had to donate, so it's an acid, and this is conjugate base. And if that's an acid, this must be the base, and this must be the conjugate acid. And we recognize that as a base anyway because it's an amine. And that is everything that's in Study Guide 4.3.